If you are new to NX, this series of Day 1 training courses is designed to get you started. You'll model some of the parts in this drill press assembly, beginning with the column. It's simple to model, with one sketch that you extrude a distance. The column support is a Revolve sketch, with some detailed features added. The drill press table uses shell and draft features. It also demonstrates several symmetry methods. The table support shows ways to unite and subtract basic solids to create more complex shapes. In this quick course, we'll draw a column sketch and dimension it. And then we'll extrude it to a distance. I'll start NX. To create a new part file, click the new icon. In the dialog, notice that the model template and units of millimeters are the defaults. I'll specify a file name and keep the default folder, which I've set to a suitable name for this demo. To finish the dialog, I can either click the OK button, or simply press the middle mouse. When you create a new part, NX opens the Part Navigator. It shows the history of your model, as you design it. NX creates a datum coordinate system, or datum CSys, automatically. To draw the column shape, let's create a sketch. By default, NX selects the top plane of the CSys as the sketch plane. That's the plane I want for the column, so I'll press the middle mouse to OK the command. The software rotates your view to the sketch plane. By default you'll get a sketch origin point, along with vertical and horizontal axes, all of which you can use to place geometry. I'll create a circle with its center off the sketch origin. You'll see why in a moment. At this point, the exact size doesn't matter. The brown curve color tells me the curve is still movable. I'll hover over the circle to make its center point active, and drag the center, to make it coincident with the sketch origin. When I click to edit the circle, NX creates a candidate dimension. Notice also that when I edit a curve, the sketch solver finds relevant relations. In this case, the solver knows the circle is concentric with the sketch origin. To set the dimension value, I select it, type 50, and press the middle mouse. I'll accept the scaling option. And middle mouse to finish the dimension. The circle switches to the fully defined color, and the status line updates. I'll create my second circle, and this time, I'll place its center at the sketch origin. The inner circle is 48 mm. Once again the geometry is fully defined, so I'll finish the sketch. In the Part Navigator, notice that my sketch is selected. So when I start the Extrude command, NX automatically previews my extrude, with the default end value. I'll drag the end handle up a suitable distance. And press the middle mouse to complete the command. Then, I'll double-click the Extrude in the Part Navigator to make an edit. I'll move the model down a bit. Press and hold middle and right mouse buttons to pan. The column should be taller, so I'll set a new value. To save my file, I'll click the Save icon at the top of the window. Next, I'll open the History tab on the resource bar. Notice that NX displays an easily recognizable thumbnail of your part. I'll stop here, and let you work the You Try It exercise. In this quick course, we'll create a column support for the drill press column to fit into. We'll sketch the support profile and revolve around an axis. If you're following my steps closely, you still have the column part open. To create a new part, press Ctrl-N. Of course, we'll use the model millimeters template, and the same folder. Give your new file a suitable name. And press the middle mouse to create the part. Next, I'll create a sketch feature. For the support, I'll choose the front plane of the datum CSys. And press the middle mouse. The profile command lets me create a connected series of lines and arcs. I'll pick a suitable start location on the sketch horizontal axis. And I click a series of points to create the shape. I'm not focusing on the dimensions at this point. My goal is to get the shape right. Notice that NX applies a fill color to the shape. Any shape closed by end-to-end points will have this fill. To dimension the outside radius, I'll first click the vertical axis, and then the outside curve. Next I'll click and drag to place the dimension, and enter my value. On your first dimension, NX will optionally scale your entire sketch. I'll accept scaling. I'll use the same steps to dimension the inside radius. 25 mm will match the column. These two dimensions fully define the bottom curve, so it switches to the standard curve color. Movable curves display in brown. So for example, I can drag this curve. Here's a second key point. I'll hover over the curve to display its control points, and select an endpoint to edit the curve. Notice that the sketch solver finds and displays geometric relations relevant to my editing selection. In this case, they're horizontal, vertical, and collinear relations. We'll look more closely at relations in the next course. For now, I'll finish my sketch. In the Part Navigator, notice that my sketch is selected. So when I start the Revolve command, NX automatically selects all the sketch curves. Middle mouse advances me to the next step. We're revolving around the z-axis of the CSIS. The default angle is 360 degrees, so I can press the middle mouse to complete the revolve. We'll continue working with this part in upcoming courses. But if it were complete, I would probably hide any features that are not part of the geometry. In the Part Navigator, here's the hide icon. Now the part's ready to save. And on the History tab, other designers can clearly distinguish your parts. In this quick course, we'll make edits to both of our parts, starting with the column support. We'll start by finalizing sketch dimensions, so I'll hide the Revolve feature. I don't need to hide the Revolve, but it will make the sketch easier to see. To open the sketch, double-click. The curve colors tell you that the bottom curve is fixed, while all others are still movable. When I select the outside curve, Sketch finds the curve ends and creates a preview dimension, which I'll set to 6 mm. Sketch axes are available for dimensioning. Picking the horizontal axis on the top curve gives me a height dimension, which I'll set to 25 mm. On the scene bar, the Make commands move curves into geometric relationships. The top curve needs to be 6 mm, the same as the outside curve. Rather than dimension it, I'll make it equal to the outside curve. I select the curve I want to move or change first. Then I select the stationary curve, and click Make Equal. All the curves are now black, and the status line tells me my sketch is fully defined. Next, let's look at the sketch solver. When I select an object for edit, the sketch solver finds the relations that are relevant to my selection. When I pause over a relation symbol, in this case, a vertical relation, the tooltip tells me I can click to relax the relation. Notice the relaxed relation color. Now I can drag the curve away from vertical. I'll undo my change, so the curve is back to vertical. Next, I'll create an angle dimension and give it a value. Notice that Sketch automatically relaxes the vertical relation. This is a key point. Sketch dimensions have priority over found relations, so you can easily change your design by dimensioning objects. I'll undo my change, and with the sketch once again fully defined, I'll finish. Let's show the updated Revolve. I'd like the Revolve to have a color that's right for the material, so I'll click the Solid and choose Solid Body from the Select Related Object menu. I'll choose Edit Object. click the color swatch, and pick an appropriate color. The column has one sketch dimension I'd like to change, so let's switch to that part. And double-click the sketch to open it. The diameter of the inner circle isn't the dimension I want. The material thickness of the column is. So I'll delete the diameter. And select each circle from outside. I'll set the distance between the two circles to 1.5 mm. Finally, the dimension text is a bit bigger than I'd like. I can hold the Control key and press the down arrow to reduce the text size. With that, I'll finish the sketch. And I'm done with my edits. In this quick course, we'll create detail features that complete the column's support. The part has 3 mounting holes, so let's start the hole command. For this part, I'll change the hole size to screw clearance. And set the size to 8 mm. On the snap point menu, make sure the midpoint option is turned on. Then place the hole at the midpoint of the sketch curve. The default depth limit cuts through the part. But I'll change from a specific value to through body, which expresses my design intent. Then I can be sure the hole cuts through the material, no matter how much the thickness changes. At this point, I'm done with the sketch, so I'll hide it. Next, I'll use Pattern feature to create a pattern of 3 holes. I select the hole. Change the layout from linear to circular. And press the middle mouse to advance to the Specify Vector step. My vector is the vertical axis of the datum CSIS. I'll set the spacing to count and span. And set the count to 3. Note that count includes the source feature. My angle is a full circle, 360 degrees. Pressing the middle mouse completes the feature. And here's my circle pattern. A seam like this would typically be blended, so I'll start the Edge Blend command. Select the edge. Type the radius. And press the middle mouse to finish the blend. The part requires chamfers on this top edge. And on both edges of this face. I'll start the chamfer command. Select the edge. And set my distance. I'll click Apply to create the feature and keep the dialog box open. Next, at the top of the graphics window, I'll open the Curve Rule menu, and change the rule from the default tangent curves to face edges. Now when I pick the face, the software chamfers both of its edges. Before I close out this demo, take a moment to note the sequence of features in the Part Navigator. I've followed a repeatable workflow that captures sound part design. A sketch defines the basic shape of the part, which I've revolved into the basic solid. Then I added detailed features and placed small edge blends and chamfers last, where they are least likely to break if the basic part design changes. In this quick course, we'll create the basic shape of the drill press table. It's a shelled part with 2 sketched shapes, the flat table, and the mounting post. I've already sketched the table profile. The sketch is fully defined, with dimensions that specify its size and its location, offset from the horizontal and vertical axes. I'll select the sketch to extrude it. The x-axis of the CSIS is the center line of the table, so I'll set my extrude limits to symmetric. The table is 160 mm wide. The table has blends on each vertical edge, so I'll start Edge Blend. Set the radius to 10 mm. And select each corner. I'll flip the part to get the last corner. Shelling the table is next. The sides are 3 mm wide, and I select the bottom face to shell. I place the blends before the shell because their radius is greater than the shell thickness. That gives me consistent wall thickness throughout. The table is a cast part, so it will need draft to come out of the mold. I'll reverse the draw direction. Remember that we're looking at the bottom of the table. And press the middle mouse to advance. I'll make the table bottom the stationary face. And set the draft angle to 1 degree. The face rule is set to tangent faces, which will let me select all 8 inside faces with 1 click. Next I'll select 1 outside face, and I have all 16 faces I need to draft. I've flipped the part around. And I'm ready to sketch the mounting post. It goes on the right plane of the datum CSys. To make the post collinear with the tabletop, I'll include the edge in my sketch. I'll select the edge. Notice that NX displays the included curve in a broken font. I'll start the rectangle command. Beginning from the sketch origin, I'll sketch out a rectangle. Next, I'll drag the top curve to align with the included curve. Then I'll drag out a circle from the sketch origin, and make it tangent to the rectangle. The trim command lets me drag to delete the extra curves. The width of the table mount, at its top, is next. I'll make it 50 mm. The curve colors, and the status line tell you that the sketch is fully defined. With the sketch selected, I'll start the Extrude command. Because the extrude cuts into existing material, NX infers the subtract Boolean. I'll change the option to Unite. Set the end distance to 15 mm. And middle mouse to finish the command. The mounting post has draft, so let's add that. I'll change the draft type to tangent to face. Reverse the draw direction. And select a side vertical face. In preview, you can see that NX has made the drafted faces tangent. 10 degrees of draft is what I want, so I can press the middle mouse twice to end face selection, and finish the command. And the basic table design is complete. In this quick course, we'll add some of the detail features the press table requires, beginning with the slots. The slots are based on a single sketch feature, extruded through the table, and then mirrored. I'll create a sketch and display the full set of dialog options. The tabletop is my sketch plane. In the dialog, I'll select the origin point option and specifically place my sketch origin at a suitable midpoint. I'll start with a rectangle in about the right location and about the right size. Next, I'll create a circle beginning from this midpoint and make a tangent to the side of the slot. Then, I'll create a second circle at the bottom of the slot. Whenever I select an object for edit, note this key point. The sketch solver automatically finds relations like vertical, coincident, and collinear. Once I add dimensions that fully define the sketch, curves will not move unless I edit the sketch and move them. Slot dimensions are next. The distance from the horizontal axis to the circle is 25 mm. The height of the slot is my next dimension. It's 125 mm. The width of the slot is 15 mm. The distance from the vertical axis to the center of the slot is my last dimension. It's 50 mm. Note that my sketch is fully defined. Next, I'll extrude the slot sketch into the table. I'll set the end limit to through all to clearly define my design intent. I'll use the mirror feature command to mirror the extruded slot. And I select the datum plane along the center line of the table. The destination point shows my mirror location. And my mirrored slot is complete. The mounting post attaches through a counterboard hole, so I'll start the hole command. Set the hole type to counterboard. And specify my hole dimensions. And the hole point will be the sketch origin point. The until next limit ends the hole at the next face. The preview looks good, so I'll middle mouse to finish. And hide the sketch. The bottom faces of the table sides have blends on each edge. So let's start the edge blend command. And look again at our curve rule options. I'll choose rib top face edges. When I select the top face, the software finds both edges along the entire chain. And with that, my edits are complete. In this quick course, we'll use Boolean unite and subtract operations to join, or subtract, solids in this table support. Unite and subtract are available as commands, and also as options built into commands like Extrude and Revolve. For this demo, I'll delete the table support solids, and rebuild them. My first feature is a symmetric extrude, which we've seen in earlier courses. The distance is 30 mm. Notice also that the Boolean value is none. I'll click Apply to finish the extrude and keep the dialog open. Next, I'll extrude the front extension by 45 mm. And I'll set the extrude Boolean option to none. And OK the dialog. To join the extrude features, I'll start the unite command. The cylinder is my target. And the tool is the extension. In the dialog, I can expand the region group and specify which portion of the united solid to keep. NX subtracts the inside region. The back extension is also a symmetric extrude of 15 mm. And the unite is similar to my first unite feature. I'll keep the outside region. And NX subtracts the inside region. The part has a slot, which I'll extrude a suitable distance. Again, it's symmetric. For this extrude, I'll set the Boolean option to subtract. And NX removes material from the solid. Next, let's edit the extrude feature. And change the Boolean option from subtract to none. So the extrude is now a separate solid. Then I'll start the subtract command. And like unite, I select a target. And then the tool body. And finish the command. Notice that the subtract command creates a feature in the model history. The result in my part geometry is the same with either method. So the question is which part navigator structure you prefer. In this quick course, we'll create an assembly file. And load the column, and column support into it. To create a new file, press Ctrl-N on your keyboard. Select the assembly template. And specify a suitable file name. I'll use the same folder, so I can press the middle mouse to create the assembly file. With the assembly template, the software automatically starts the assemble command. And shows the assemblies tab on the ribbon, which I'll display. Next, I'll open both parts into the assembly. Components come into the assembly scattered, and I can move them freely. But for this demo, I'll apply constraints to position the components. I'll start by fixing the column support in place, along its center line. For each selection, or selection pair, NX displays a constraints context menu. In this case, only the fix constraint is appropriate. With the support fixed, I'll align the parts along their center lines. Using the touch align constraint, I can use touch align to align the bottom faces as well. Next, let's look at the Assembly Navigator. It shows the structure of my assembly, beginning with the parent, followed by its component parts, indented because they are children of the assembly. Note also that my constraints appear under the Constraints node. If I switch to Wireframe Display, you can see the constraint symbols in the graphics window. To modify a part in my assembly context, I can make it the work part. The software switches other components to see-through mode. And when I switch to the Part Navigator, I see the work parts features. The column should be taller, so I'll double-click to update it. And set a new end limit. To complete my work, I'll go back to the Assembly Navigator. And make the assembly the work part. With that, my basic assembly is complete. In this quick course, we'll create a basic drawing of the column support, with these 4 views. Open the part you want to create a drawing for, and press Ctrl-N to create a new file. In the New File dialog, click the Drawing tab. And select a size. A3 will work for the support. Notice that the software assigns a suitable name to your drawing file. Press the middle mouse to create the file. Next, you'd fill out the title block according to your company standards. For this demo, I'll specify a couple of placeholders. And close the dialog. The software automatically opens the base view command, and is ready for you to place a top view. I'll place the view, and for this demo, I'll close the dialog. Next, I'll add an isometric view in the upper right side. Right-click the dashed sheet border. And choose Add Base View. I'll choose Isometric. Click to place the view. And close the dialog. Next, I'll add a section view through the part. For that, I'll right-click the border of the top view. And select Add Section View. Click the center point to locate your cutting plane. And then click to place the view. To add a detailed view of the section, right-click its border. And choose Add Detail View. I'll click the whole center. To define the center of the detail, and click again to set the detail size. I'll place the view to the right. To reposition a view, just drag its border. Next, let's make the isometric view shaded. I'll right-click its border. And select Settings. On the Shading node, change the rendering style from wireframe to fully shaded. And press the middle mouse. Dimensions are next. I'll zoom in on the section view. Create dimensions with the Rapid Dimension command. I'll create a couple of the dimensions you'd add to document this part. First, the inner diameter where the column fits. And then the outer diameter of the support collar. And my basic drawing is done.